please welcome professional American and man-child Ken Wheeler.
It's the final countdown. The final countdown. Oh, we're headed for Venus. And still we stand.
What up? Let's get this situated here. Last talk of the day. Wakey, wakey, bitches. Am I mirrored? Can I get the one down there? Sorry. All right. All right. I'm Ken Wheeler, CEO of Wheeler Defense Systems. I'm also the director of open source at Formidable and the American ambassador to Banterberry. And I'm here today to talk about making robot weapons with React. I'm going to start off with a disclaimer. I have little to no knowledge about actually making robotic weapon systems. I spend my day configuring Webpack just like the rest of you guys. However, I did build a totally sweet robot crossbow. It's called the Crossbow, and I think you're going to love it. Now, the folks down in marketing put together this little video. They could probably explain it better than me. I'm going to go ahead and toss this up. America. All right, yeah. So you can see it's some pretty advanced shit. All right, so let's talk about the specs on this bad boy. It's Arduino based, right? It's got a 50-pound draw weight on the crossbow, shoots 150 pounds or feet per second, right? Powered by a single, that's right, a single 9-volt battery. It's remotely controlled via Bluetooth, via a controller app that I wrote in React Native. And yes, indeed, it does have a frickin' laser beam. That's always the plus. So you might ask yourself, why? Why would a person create a fictional defense contracting company and make a robot crossbow and come on stage and talk about it? There's the obvious. I also really enjoy crossbows, and I'm a big fan of recreational archery. And I like Arduinos a lot. And if you don't know what an Arduino is, it's an open source electronics board that you can prototype on, or you can build things all the way with. It's based on the ATmega microcontroller. And you normally write, it's like a C variant, the Arduino language. but anything that compiles the bytecode will run on it. And it's got its own IDE and bootloader, so it's pretty easy to work with. Now, like many people who have an Arduino, most people who have an Arduino, this is all they do. They make an LED blink, like Dustin was saying. I can't tell, it's like you go, you make an LED blink, you put it in the box, 6 months later, you're like, this time I'm really gonna do it. And then LED blink and another 6 months. So this time I really wanted to make something, but the problem there, the reason why it's so hard is that you actually have to get components, and it's not just electronics, it becomes electronic engineering, software engineering, mechanical engineering, none of which I'm qualified to do, but I made it work. So I'm gonna tell you how to build one. So the first thing was the bow selection. Very important. Went on Amazon and got this puppy for 15 bucks. The reason I got a pistol one, right, is because you have to take weight into account. If you have too heavy a one, the servos are going to cost a fortune. It's going to be super weird. So yeah, this one did just fine. Perfectly deadly, but very small and very lightweight. So next up, you want to do pan tilt with servos, right? We want to move it around so it looks sweet. A servo is a type of motor, right, that has a fixed range. So unlike other motors where it'll just spin forever, this is a bit more granular and it has a fixed range, so you can move it to wherever you want. The first one that I ordered was a little small. It wasn't going to support a crossbow, so I taped a picture of Chuck Norris to it, and it was awesome. But I ultimately settled on these servos by a company named Robot Geek, which is pretty heavy-duty stuff. So it worked out. It totally moves crossbows. Worked out really well. Next up was pulling the trigger. Do you have any idea how weird it is to Google how to pull a trigger robotically? I'm like, oh boy. No, and there's no results for it either. Nobody's touching that with a 10-foot pole. Like I looked on forums and people are like, So I had to figure this one out organically. So after a little bit of trial and error, right, I ended up with a linear actuator. So I love this GIF. Keep your mind out of the gutter. But what a linear actuator does is, so it's a motor that spins like a screw, like a threaded screw, and that thing just, and you get constant force, and they're actually super powerful. So these things will lift like 200 pounds. So that's what I needed. And here's where we ended up. Mini linear actuator right there with a super high-tech screw going through it. It goes across the trigger, and it worked out pretty well. You control that with 2 relays right there. Relays are, they cut power on and off to electronic components. You have to put 2 of them to reverse the polarity, because the polarity determines the direction. So that makes it either extend or retract. So let's talk about powering it up. This is all we need right here. I'll tell you how that works. So an Arduino runs on 5 volts. Right? You can see one plugged in here. You can just plug in the battery, you're good to go. However, if you install a sensor shield, right, you get access to the other, 4 volts or so? Whatever it's not using, you have access to, and then that's how you could power servos and linear actuators. So you're actually able to power this incredibly deadly remote-controlled wireless weapon with a 9-volt battery. Makes it delightfully portable. So we needed to communicate with it. And I was originally going to do Wi-Fi, but then I have to be within range of a Wi-Fi network, and that's not really how I roll. So I wanted this to be able to do it anywhere. So I went with Bluetooth Low Energy, and this is the HM10 module, right? You can connect to it, and it'll receive data wirelessly, and then it'll send the data to the Arduino with serial in-out over the TX-RX ports. Now, I know you guys are wondering, what does any of this have to do with React at all? I'm happy to tell you. In our software section. So I had a couple goals here with the software. I needed to move the crossbow, shoot the crossbow, and do all this wirely via Bluetooth. So right from the get-go, I wanted to use React hardware. Unfortunately, the final product was not able to use React hardware, but we got really, really close. There were a couple hang-ups, namely the serial communication. But I'll show you what it would look like. So right here, Dustin made a lovely branch of React hardware on his fiber branch. You see that nice array return there? Where you can see the components just laid out just like that with React hardware. You have 2 servos, you have the laser pin, and then the 2 pins for the relays. And would have been really lovely, but we didn't get it in time. I was asking him about it. He's like, PR is welcome. I'm like, so what are you going to do? I'm going to make it work eventually. It's going to be sweet. So what I had to do is I had to write Arduino code for this specific thing. But I mean, yeah, if you guys are doing projects at home, most of the time you'll be all right with React hardware. This is just a little crazy business. So let's talk about some basic Arduino. So in an Arduino program, you have 2 methods that are always going to be there, your setup and your loop. So in your setup, that's where you're going to go and assign pins. And then in your loop, that's where you listen to stuff and make stuff, pull triggers, and what have you. Here's a pin example. If you've ever done Arduino, you're probably familiar with this. In the setup, we set a pin mode to output, right, which lets it write. And then in the loop, you're doing a digital write high, a delay, which will wait for a little while, and then a digital write low. And what this will do is it'll make an LED blink. So let's talk about a little bit more advanced Arduino. Serial communication, which was really, really hard, believe it or not. So on your Arduino, you have the TX-RX port there. And if you plug stuff into there and it sends over data, you can then read it in your code inside of the microcontroller. So over here, we could look at some code about how to do that initially, right? So in your setup, you're going to say serial begin at 9600 baud. That's going to set it up. And then in our loop, we're going to have a while serial available, right? So while we're able to read from it. In here, we have to do some funny stuff. So serial, I hadn't experienced something like this before, this kind of limitation, but it was a huge pain in the ass. You have to read 1 character at a time. So I wanted to send over like XY coordinates and what have you, but I could only read 1 character at a time. So what you have to do is, I say received equals serial read, and then I build up this data string, and then you use end characters. Right? So here the $ is the end character. And you're going to sit there and you're going to listen to it until you hit that end character. At that point, you're going to go check what you have, right? So first off, firing the bow, that was pretty easy. There's no coordinates involved in that. Believe it or not, I check the data, and if the data is fire, we're good to go. We can shoot the bow. We call extend actuator, delay. Sorry, I keep nipping this. Retract actuator, delay, and then stop. Right? And there, we're just toggling those pins on and off, and that's what makes the trigger puller pull the trigger. Moving the bow is a little bit more difficult because we had to use coordinates. Right? So if we look in here, in our setup, we're going to attach to the servos. And then down in the loop, we're going to listen for that data to come through. If it's not fire, it's probably a good bet that it's going to be positional coordinates. So we can get the index of the pipe, split on it, and then take those values and convert them to integers for use. Then down further in the loop code, when we actually control it, we use servo.write microseconds, which is going to tell the servo to go to a particular position, and then delay 15, which will give it just a little bit of time to get where it needs to go. So yeah, enough with all that hardware talk. This is a React conference. So let's talk about React Native. So I had to build a couple things in React Native to actually get this to work properly. I needed to connect to the Bluetooth dongle on the crossbow. Then I needed to create a UI joystick and a fire button. Most of the magic behind the connection is via a library called React Native Bluetooth Serial, which is awesome. The way to use it is if you have a component, right, you just create in your state, connected is enabled and devices to keep track of what you're connecting to. And then down here in component will mount, you do a promise.all to check, say, is it enabled? And then give me a list of devices, right? So if everything's all good, you come down and you set that it is enabled and that you have the devices in your state. Then you're going to check if it's connected. If it's not connected, you're going to connect to it by default. I also have a button that can connect and disconnect to it, but when you fire up the app, if the crossbow's in range, you're just going to go ahead and connect to it. Once that's connected, you can send serial messages from the phone over Bluetooth to the crossbow. Here you can see the handle joystick and handle button methods on the main class, where you're saying, Bluetooth serial write, then those piped limited coordinates, or you just write fire like that. That easy, yeah. So I want to talk a little bit about how I built the joystick. This is the app right here. The joystick was kind of funny because it's not the usual kind of UI that we were writing. It's to control robotics, so it works a little bit differently. This doesn't go to those positions. You go to the top right. It's not like the crossbow goes to that position. You're setting a velocity for it to move in that direction, which is interesting. This is what it looks like. It's configurable. You can set the size of it. You have the callbacks for on, move, and release, and then you can set the range, what it's translated to. So if you're moving, the range is 0 to 1023 in either direction necessarily. Then in the render, it's all views all the way down. I'm a big fan of using JavaScript whenever possible in React Native, and using views at that. So that whole thing, both pieces are all controlled by views here. You have the container, then you have the X and Y, which are the intersecting lines. You have your handle, and it just has a pen responder on it. How the magic happens, so to say, for your joystick is in componented mount, you're going to go and set interval for the output loop. What this does is it kind of emulates how the actual hardware joystick works, where it's going to be constantly transmitting that information if it's enabled. If you're touching it, it's going to be, on an interval, it's going to send those coordinates to the crossbow to move it. You unmount, you get rid of it. In the output loop, you just call that prop and it'll send it over. For the fire button, this was a really interesting piece of UI for me. Ever since I started this project, every single person I told about it is giving me a hard time. They're like, what are you, crazy? You're going to screw this up. My wife's like, are you serious? And everyone was really upset. So I wanted to take safety kind of seriously. Not just because other people, I care about safety, but So the fire button is kind of an interesting setup here. Right? It's a safety button. So I don't want to butt dial kill anyone. So this button here, you have to touch either side before it's actually active. You can't just graze it. So that was kind of interesting to build. That's also just views. If you look here, you have your safety button. You have an on-click and on-fail callback. Down here in your views, you have get container styles, get left styles, get right styles. It's just all views that are just background colors and everything like that. You have a pan responder there. And then the magic there is in your pan responder release, right? So when you take it off, we're checking if you hit left or if you hit right. And if it satisfies those two requirements, it's going to call the on-click prop. If it doesn't, on fail. And then you reset all that stuff there. So even after all this, you're probably going to ask me why. Still, why? Why would you do this? And sort of, I guess, for fun, right? But a lot of us go to our jobs every day, make a fetch out to REST API, comes back, display a list, mark that one done in Jira. All right, what else am I going to fetch and put in a list? And that's cool. We get paid good for it. But that at the end of the day, there's a lot of things that you can do with React. A lot of weird things. I spent the last 2 years, fetching lists and configuring Webpack, and writing tooling. And I think tooling's in a pretty good place right now. I mean, not to say that we can't have more tools or different things. We're having a lot of fun. But this year I wanted to actually build some things and some different things. And React plus React Native makes that kind of special because it's portable, super portable. Like robot crossbow that runs off of a 9-volt battery portable. And I think that's pretty great. And I think we should all build some stuff It's really not that hard with React. Yeah, we're going to demo this thing. So yeah, I think they're going to bring that over. And if Phil Pluckthun could come to the stage. All right, hold on. Quick story before we do any of this, right? All right, so this is not the crossbow that we were seeing in the video. I was originally going to bring it here. I got like weapon import permits for like the UK and shit. It was crazy. And then they were like, you know, and I was like, so like I had this dude buy one here, and then he was going to bring it to me, so I didn't have to bring it through customs. And then they're like, I'm like, okay. And they're like, how about we do Nerf, right? So they got this this Nerf Rebel small girl's crossbow. Now hear me out, all right? I came here yesterday and they got me this huge knife and it was sweet, and I cut the bottom off that thing to make it work, and you know, there's a lot of duct tape in play. It fires like 1 out of 3 times. You know, it's not designed for this, so it doesn't fire that reliably. But it's yeah, let's just give it a go. I'm just setting you guys, it's not like, yeah. Oh, by the way, this is the newest Formidable, and this is how we're bringing him in. Can everybody give it up for Phil? Whew. Also, let me know, this is in no way officially sanctioned by Formidable. At all. Oh, boy. All right, dude. Watch out, pretty deadly. Oh, yeah. All right. Get my thing here. All right, hold on 1 second. You guys are all going on Instagram. Deal with it. Deal with it. Okay. Sorry. Just opening up my robot app. Oh no! I'm just fucking with you. See, I told you, totally sweet laser beams, right? Sorry, dude. Okay, yeah, I think that's about where we want to be. Let me just make sure we're in top condition here. Ah! Fucking shot! Thank you guys so much. All right, I guess I got to do some questions now. All right. All right, we're gonna have some fun. Do I just pick them, like what's at the top? All right, yeah. Hey, Ken, what's it like living in your world? Hold on. A lot of freedom. A lot of red meat, projectile weapons. I'm a family man. We like to have fun. That's all I got for there. Why haven't you put it on a drone? I wanted to, but it's really weird with the weight. So I have a DJI Phantom, and we taped a machete to it, and it was sweet. But it's really funny with the drones, right? Right? When you put stuff on them, it throws off the balance. So around Halloween, right, I took like this plastic skeleton, and then I tied it to the drone, and I was gonna like fly this plastic skeleton down the block and freak all the neighborhood kids out. And it was crazy because like it started swinging and then like threw off like the rotors, and it was like crashed my drone. So yeah, that's why I haven't put it on a drone. How did you get to be so handsome? I have pretty good-looking parents. Spent some time in the gym of decent stock. I suppose you could chalk it up to that. Red meat. How would you optimize this weapon for defense against ninjas? Man. First of all, probably night vision. Because I know that they come out at night. I'd probably make it silent like a ninja. I'm trying to think of other ninja-type characteristics that I could account for. And, I don't know, dude. I'd just shoot the ninjas. It wouldn't even be a problem. Any open positions in Wheeler Defense Systems? Come see me at happy hour. When will the crossbow be available for sale? They're made bespoke. So if anybody's interested, you can hit me at ken@outlook.com, and I'd be happy to put it together. That's actually my real email. I had a brother that worked at Microsoft. Holla. I still have the brother. He just doesn't work at Microsoft anymore. Can we control it now? Who asked that question? Who did it? I'm serious. Come do it. You can control it. Come on. Yeah. Here. Go to town, dude. Point it at the audience. Let me just make sure it's connected. Oh, yeah. It's party time. Go get him. Sure. Yeah. Yeah. No, there's, no, you're going to shoot it. You can control it. Laser's pretty sweet, right? Are you going to shoot me?
It's nice.
All right.
Thank you.
Oh, thank you. All right. Do you have any plans to add motion tracking to the crossbow? Another funny story. So I originally wanted to add a camera to it and use OpenCV to do like blob targeting, right? Which would have been totally sweet. Except, again, I'm a family man. I have a 2-year-old running around. So you probably shouldn't create these autonomous kill weapons, that just like shoot blobs. I don't know. That would, no. Does it have any tests? Yeah. I use Flow, so don't even worry about it. What's the craziest project idea you've thought of? You're gonna like this. Okay. So I made the crossbow, right? And it was like chill, right? And I was like, yeah, it's cool. It's a crossbow. What else could we do? So the next evolution of this that I'm probably going to do, you guys have seen like model rockets, right? So I'm going to create a missile battery, right? And it's going to take model rockets, and it's going to be like, just terrorize New Jersey with it. It'll be good. Could you connect it to Twitch so we can all vote on how it moves and shoots? Cheers. Yeah, probably could. I mean, yeah, as long as you forward the Bluetooth messaging and connection, you're good. So you could just, you could shoot someone with it halfway across the world. Nobody wouldn't even know about it. What is the future of radium? She's gonna throw that one at me? So the radium talk. Yeah, we do use styled components. I can't speak personally as to what the actual future of radium is. I know internally, we use a lot of things, CSS modules, styled components. I could get you a definitive answer on that. What's next after the crossbow? I don't know, like for hardware projects or for projects in general. I got to write some fiber custom renderers next month for Amsterdam, so we'll see how that goes. Is Bluetooth safe for this kind of toy? This isn't a toy, bro. Fuck. One more? How much effort, nice name, how much effort would it be to bring serial port capability to React hardware? I don't know. Probably not that hard. You would just have to, expose the one board global properly, and then just send it over through there. Probably doable. Yeah. Awesome. Thanks so much, everybody. Oh. Can I say one more thing, dude?
Yeah?
Yeah. So fuck. Sorry. Really? Yeah. So I have one of these shirts. Only one of them, except for the one that's on me. And one person can get it, right? At happy hour, right? And you have to take it from me physically. Sorry, again.
Thank you, Ken.
No problem, dude.